Welcome GibbsCAM users. Today we're going to show you what's new in GibbsCAM version 2024. In this specific video we're going to show you what's new in form tools and how to program form tools. This also applies to regular straight shank tools as well, but this is something new in 2024 we're going to show you. So if I open up my tools, as you can see I have my part here. All these cavities are the exact same size. If I turn on the geometry, you'll see I have geometry at different levels on all 6 cavities here. And the first tool I have is just a standard 1/2 inch tool here, but notice I have an 1/8 of an inch radius on the corner. This would apply for any size tool that has a radius on the corner and not a straight shank. And I have 3 tools here, 3 form tools. If I look up my form tools here, well, first let's show you what the form tool actually looks like. So here's the form tool, just a standard 1/2 inch shank here, 1.5 inch diameter here, and I have a 110 degree taper here, 1/4 inch here. You can see all the dimensions here. So this is what my form tool actually looks like. Let's open up our cam. So on the first operation, which is right here, we're going to program this cavity right here. And I'm going to tell Gibbs that it's 1 inch deep, the geometry, and the depth of the tool, I want it to go 1 inch deep, standard stuff that's in Gibbs all along. So when I render this, let's do a simulation here. I'm going to single block it, so let's rewind it. Single block. As you can see, it's cutting larger than the cavity I want it to cut. As you can see here, if I zoom it up, you can see we're overcutting the dimension here. I want it to cut this 5 inch by 5 inch square, but as you can see it's cutting larger than that. And I get calls on this every so often wondering why is it doing that. And I told it there's my tool, there's my geometry, why is it cutting outside the boundaries? Well, if I bring up a little drawing here of what the tool looks like, it'll make a lot more sense. So if I show you this drawing here, you can see I have my geometry. Let me zoom this out a little bit and get it so we can see it here. Okay, I have a 1/2 inch tool with an 1/8 inch corner radius, and the geometry was drawn, or it was told it was at Z-1 inch. So my geometry for my 5 inch by 5 inch cavity is at -1 inch there. So what Gibbs is looking at the geometry that was at Z-1 inch. Well, at Z-1 inch, you can see the diameter of the flat of the tool is 1/4 inch right there. You can see it here as well. I have an 1/8 of an inch corner radius, so that means the flat on the end of the tool is only 1/4 inch diameter. So since you told Gibbs it was at -1 inch, Gibbs is calculating what the tool diameter is at 1 inch deep. So Gibbs thinks, well, okay, I'm only a 1/4 inch diameter there, so I'm going to bring that 1/4 inch diameter to my geometry, which is at Z-1 inch. So if I bring up the operation again, you can see I told Gibbs that the geometry is at -1 inch, and the depth is also -1 inch. So Gibbs is calculating that based on the tool shape of the tool at -1 inch. So that's why you see when it's cutting oversize on there, because it's looking at the tool at -1 inch. So now I go to the second operation, and this time I said to Gibbs that the geometry is only a 1/2 inch deep, but I want the tool to go 1 inch deep. So at a 1/2 inch deep, if I bring my drawing over again, so at a 1/2 inch deep, the diameter of the tool, of course, is a 1/2 inch right there. So at a 1/2 inch deep, and we run that in simulation, you can see it's going to bring the tool exactly where we want it to, right along the edges there. So in the last operation on this third cavity here, if I zoom up and go over to that one, single block through that. Now the third one, the third operation, let's bring that up. I said the geometry is at 0, and I want the tool to go -1 inch. This is usually how I like to program. I usually like all my geometry up at the surface where the material is before I cut it. I usually don't like to have it at the bottom of the part. That's okay though if you want it at the bottom of the part. You just have to remember the rules for the shape of the tool. Now if the tool didn't have a corner radius, if we said it was 0, then we could have this operation number 1 at -1 inch and tell Gibbs that the geometry is also at 1 inch and everything will be just fine. But most tools don't have a square corner. They have at least a 5 or 10 thou corner radius, but if you want it to realistically show you that in your simulation, then you should be putting in what the actual radius is of the tool. So as you can see, the third operation goes right along there just fine. So nothing new there. This is the same that's always been in Gibbs, the same way it looks at tools. And I have another video on corner rounders that show you how to use corner rounders using this same method here. So if I go to the next tool, which is a form tool, let's bring that one up. This is what my form tool looks like. I showed you a picture of that a little earlier. But this is what the tool looks like. I have a solid model in my body bag here. Let's bring that out. There's my form tool that I showed you before. Let's put this back. So I clicked on Form Tool, 3D Form Tool, said Apply, and it drew the part. Now the new thing that's in GibbsCAM 24 is you have the real profile here, which is what I did on this tool. And I created the same tool again in tool number 3. But this time, you see you have a drop-down menu. This time I said it's nominal parameters. So what it's looking at is the outermost shape as the tool, as if it was totally square and sharp corners. So whatever depth you tell Gibbs, it's going to apply this 1.5" diameter to it. Then the last tool, same form tool, this time drop down monotonic profile. This time it's looking at the outermost shape and all the way to the top. So if you told it it was going deeper than from the bottom here up to here, then everything would be considered its 1.5" diameter here. And let's show you that as well. So I'll open up my cam. I'm actually going to deactivate these. Okay, so operation number 4, that's using tool number 2. Let's bring that tool up. And you can see this is the real profile. So whatever depth I tell it to in Gibbs, it's looking at the profile of the tool. Now if I bring in the form tool again, let's just kind of zoom it over here. You can see that anything that's farther up than 1/2 inch, I'm going to be looking at this diameter here. Anything higher than that's going to be looking at the diameter here. Let's move this out of the way. So in this operation number 4, I'm using tool number 2. And I told Gibbs to go ahead and look at the total diameters of this form tool here, the real profile. So I said, okay, in Gibbs, that my geometry is 3/8 down from the bottom, so it's 3/8 from the top down. So that would be, it's 5/8 from the bottom up to that geometry there. So minus 375 would make 5/8 down there. So if we look at this form tool again, you can see there's 1/2 inch. And if I'm 5/8 from the floor, it's going to be looking at this tool right about here. And of course, the depth I want to go is 1 inch deep. So if I render that, there's the tool. As you can see, it's going around. It's just barely touching the sides. So it's really not cutting anything because our cavity is already 5 by 5. So, but you can see it's looking at a tool as if it was 5/8 off the floor. Okay, so the next one, tool number 3, I told it to look at the tool as if it was the full diameter, 1.5 inches, all the way to the tip, all the way to the top. So no matter where I put my geometry, or tell it where the geometry is, I could put this at 0 or -1 inch. It won't make any difference. If I put it there, if I put it at 0, you can see it's not going to make any difference there. Put this back at -1 inch. But on the last one, it's using tool number 4. So this is the same tool, but this time I have monotonic right here. So what it's looking at is the full diameter from the largest diameter all the way to the top. But anything below that, it's looking at the shape of the tool. So on operation number 4, I said the geometry is at -1 inch, and I want the depth to be -1 inch. So when I render this, let's get through these here, this one and the next one. All look good. Now the last one, we'll zoom this up. If I cut into that, now you're going to see what it's looking at -1 inch. Let's bring up the operation again. At -1 inch, so I'm telling Gibbs the geometry is at -1 inch. And of course I want to go 1 inch deep. So what Gibbs is looking at is the diameter of this tool at -1 inch. So that would be 1/2 inch. So that's why you're seeing it cut, but you can see that 1/2 inch right there, the diameter of the tool, is matching up with the geometry on the bottom of the part there. If I finish this out, you'll see up and out. I have my taper, my groove. So it all depends on how you want Gibbs to look at form tools. And when you're using a tool from the library, anything here, and if you click on options and give it a taper here, it's looking at this profile of the whole tool like if it was real profile. So with regular tools, you don't have the drop-down menu that tells you different ways to look at it. This is only for form tools. So if I render this again, there you go. So whether or not you decide to put your geometry at the top level or wherever your material is that you're going to cut, or put it halfway down, all the way down to the bottom of the cavity, that's totally up to you. You just need to tell Gibbs where to look at that geometry, at what level. Look at the geometry at 3/8 down. Look at the geometry at 0. Or look at the geometry at 1 inch. And then when you're working with form tools, you have the real profile. It's looking at the profile of the whole tool. Or nominal parameters. It's looking at the largest diameter of the tool all the way to the top and all the way to the bottom sharp corners. Then the last one, monotonic, is looking at the large diameter of the tool all the way to the top, but anything below, it's looking at the form of the tool. So be careful using this. If you want to always program with the largest diameter, then I would probably suggest you use nominal parameters there. But this only works on form tools. But also beware when you're using regular straight tools and you have a corner radius, make sure you tell Gibbs where you want to calculate the geometry from. As in this first one, -1 inch. It's looking at the tool, clear to the bottom, so it's going to offset that radius. If you told Gibbs, as in the second one, that you're like ½ inch deep and total depth -1 inch, or usually how I program, put your material right here where you're starting the material from and the depth, and leave your geometry at the top, and you'll be fine. You won't have to worry about that radius on the corners of the tools. So hopefully this helps with the new choices you have in Gibbs for form tools. It works really well, and it'll help you in the future when you're using some special form tools you import as solid models or draw in 2D geometry. It's up to you. But thank you for watching.